Hello everyone, I hope you are doing well. So in this video we are going to discuss Leetcode problem of the day, and today's problem is minimum falling path sum, and it is a medium level problem. So the problem says that we have been given an n cross n matrix of like integers, and we have to find out the minimum sum of any falling path. So what is a falling path? Let me just take this particular image. Can I paste it? Yep. So as you can see that if I start from this particular point, I can go to either left or right, or I can go directly down. These are the three possible ways for me to go, right? And when I'm here, I can go to left or down or right. But since there are no right elements, these are the only two options that I'm stuck with. Now I can start with any of these elements in the 0th row. So I can start with 2, then 1, and then 3 as well, right? So following a falling path, which means I can like either go left, down, or right if they are available options. I have to figure out the minimum sum on any of these paths, right? So in this case, you can see if we calculate the sum on this path, this is a valid falling path because from here we are going one step downwards, and from here we are going left, right? So the answer will be 7 plus 5 plus 1. So that is 7 plus 1 plus 5, that is 8 plus 5, and that is 13, right? So the sum on this first path will be equals to 13. The sum is 13 here, right? Now if we consider the second path, it is 1 plus 4 plus 8, so 8 plus 4 plus 1, it is also 13. So both of these paths give the minimum sum, and that is 13. So 13 will be the answer. If we consider other paths, it might give us a greater answer. So let us just try to do this once. So if let's say I start from this particular 3, then I move on to this 4, and then I move on to this particular 9. So the total sum will be 9 plus 4 plus 3. So that is 13 plus 3. So that should be 16, right? So this is how you can solve this problem. You just have to figure out the minimum sum path. So now the question is, how do we actually code it? Now you will realize from each of these paths, let's say I am suppose at 5, I have three possible ways, right? One is to go towards the left, then the other one is to go towards the bottom, and the third one is to go towards the right, right? So with these three possible ways, I want to choose the minimum among them, right? So what I'm going to do, I'm going to maintain a DP state. You can call it DP, or if you don't want, you can give it some other name as well, but let's just call it DP for now, right? So what is DP of ij going to denote? DP of ij is going to denote the minimum sum if I start from cell I comma j, right? So this should be my minimum sum if I start from the cell I comma j. Now what should be the minimum sum if I start from 5? This is my question now. The minimum sum will always have this value 5, that is for sure, that is the value of the current cell. Now I have to take the minimum among these three, right? I don't know what further rows can be there and what will be their answer, but I know that I can move to these three cells and I should be taking the minimum among them. So what I will basically do is, let's say I am here, so I will check the minimum value in I plus 1 j minus 1, then the next value will be I plus 1 j plus 1, and then third value will be I, so it can be j only, I plus 1 j, the column does not change, and the third value will be I plus 1 j plus 1, right? So these will be the three cells that I want to check. One is the cell that is present to the down left, the second cell is the one which is present directly down, and the third cell is the one which is present in down right position. So out of these three cells in which I can go, I can try to find out what is the minimum answer if I start from these cells. And how will it be stored? It will be stored in dp of, let me just write it. So let's say this is 0th row 1 and 2. So for this particular cell 7, the answer will be dp of 20. So in dp of 20, I will already have the answer what will happen or what will be the minimum sum if I start from this particular cell, right? Similarly, in dp of 21, the answer will be for this particular cell, and dp of 22 will have the answer for this particular cell. I can take the minimum among them, and that will denote what is the minimum sum I will have to take if I move on further from this cell 5, right? I take that particular minimum, let's say it is equals to best, I add the value of the current cell, let's say matrix of 1 1 in this particular case, and this will be the minimum sum that I'll have to form if I start from this particular cell, right. Similarly, this will keep on continuing and we will keep on decreasing our rows. Now at the end what will happen is either I can start from here, I can start from here, or I can start from here. So my answer will be the minimum of dp of 0 0, dp of 0 1 and dp of 0 2, right. Among these three cells I am going to take the minimum. So this would be my final solution. Now let me show you the code. So the code is very simple. Actually I have taken two different dimensions n cross m, but since it is a square matrix, so you can only take one of them. I have created a dp array of size n cross m, and for the last row you will realize that there are no further rows, so the answer of that particular cell will be the value of the matrix itself. So what I am saying is, for this particular cell 7 there are no further values, right. So the maximum sum starting from here will be equal to 7 itself. Similarly for 8 and 9. So that is exactly what I am doing here in the last row, right. Now let us focus on this part first, then we will discuss these for loops. So now my best answer is dp of I plus 1 j, that means the element that is just directly below my current element, right. Now if j is greater than 0, I am going to go towards the bottom left. If j is less than n minus 1, I am going to go towards the bottom right. Now my best will have the minimum of all of these three values. So dp of ij will be equals to best plus matrix of ij, where matrix of ij is the value of the current cell. So what I have essentially done is I have taken this value of current cell and added it to the best value. What is best? Best is the minimum value among the like the directly bottom, the bottom left, or the bottom right, right, because these are the three positions I can go to. At the end what I have to do is, since I can start from any cell in the 0th row, I am just going to take the minimum element starting from dp of 0 till dp of 0 plus m. So this will be my final solution, and let me just quickly submit this and show you that this particular solution works and this code is absolutely correct. So you see, this passes all the test cases and the solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.